do the next ones, I just want you to pause it, and can you have a go at trying these ones yourself? I'm just going to put a square on the U's for you. And there's one that we haven't talked about yet. Tan here. I'm going to tell. Oh, we have talked about tan actually. Sorry. Tan was on the page 2. Tan differentiates to sec squared x. So can you pause it and have a try of those? Then all I'm going to do for these is I'm just going to write down the answers, and we're going to look at how I got the answers really fast. So all I'm doing on my head look is I'm differentiating my u to get 3. Then I'm times the by, well, sine differentiates to cos, and the function just stays the same. This one, I'm differentiating my u, so x over 2 differentiates to give me a half. And cos differentiates to give me minus sine, and that just stays as x over 2. I'm differentiating my u, so 4x differentiates to 4, tan differentiates to sec squared, and my function just stays as 4x. Differentiate my u, so my u differentiates to minus 5. Differentiate e stays as e, and the function just stays as minus 5x. Here I'm differentiating my u, so x over 7 differentiates to 1 over 7. Differentiate e stays as e, and the function stays as x over 7. Differentiate my u, so 5x differentiates to 5. Differentiate ln, which gives me 1 over my thing, which is 5x. Now I'm just going to simplify this one. So 5 times 1 over 5x is 1 over x. So we'll talk about the integration step in a second. Now, if these are my y's, then hopefully by the exercises above, you can just spot that when there was sine x, sine kx, sorry, the k went to the front. So it's just k, and went to cos, and the angle stayed the same. When it was cos, it changed to minus sine, both at the k at the front. So it's minus k sine kx. When it was tan, the k, which was 4 in this case, went to the front. And tan changed to sec squared kx. E, the k went to the front, and just stays as e to the kx. Ln kx, well, the k went to the front, and times the by 1 over kx, and that's simplified, give us 1 over x. And 1 over kx, it's not 1 on there, but that just means 1 over k x to the minus 1, which gives us minus 1 over k x to the minus 2. I'll do a video on stuff like this afterwards. Okay, so let's use the quick rules on these at the bottom, and hopefully you're going to see the difference about where I put the 3, how important each one is. So here, I don't have a u, because it's just x, so I don't need to worry about changing it. So if I differentiate cos x, I get minus sine x, times by the 3 at the front. So I just get dy by dx is minus 3 sine x. For the second one, I do have to use a u though, because I have 3x. So what we do is, using that quick rule at the top, I differentiate my u and I get 3. I differentiate cos and I get minus sine. And then the angle stays the same. For this one again, we have a u. So I differentiate my u and I just get 1, because x differentiates to 1. Differentiate cos, I get minus sine. And then the angle stays the same. And then the last one, this one's a sneaky one. So cos cubed x, well, but always when we differentiate with trig, write out what that means. So that means cos x cubed. So now you should be able to spot that it's this bit. That's the u. Okay, so I'm going to, for this one, I'm going to just try and use the quick trick. So to use the quick trick, I differentiate my u. So cos x differentiates to minus sine x. And then I get u cubed. So I differentiate u cubed and I get 3u squared. So I need times by 3 times by u squared. So I get minus 3 sine x. And then stick what u was. So it was cos x squared. Then just rewrite it with our usual notation. So sine x cos squared x. Okay, I'll do the next one because it's similar using the u method. Okay, so next one, cos cubed ln 2x. So first thing is to rewrite that as cos ln 2x cubed. Well, this one, it's a chain within a chain. So my u is cos ln 2x. So therefore, my y becomes u cubed. Differentiate y, we get 3u squared. Differentiate this u here, and you could use the chain again if you need to. I'm going to see if I can convince you about the quick way. So ln 2x would differentiate to 2 over 2x, which is 1 over x. Cos differentiates to minus sine, and the angle stays the same. And then the chain rule says times these two things together, so dy by dx is minus 3 over x sine ln 2x times u squared. Sub back in what u is, so it's minus 3 over x sine ln 2x, and u was this, so it's cos squared ln 2x. Yeah, that was a bit of a tricky one. Yeah, for this bit here, you could use another chain to get where that comes from. I'm just using that quick method. Okay, the last example we'll do is show that if I differentiate sec x, we get sec x tan x. So for this one, what I'm going to do is I'm going to start off by writing y equals sec x. So y equals 1 over cos x, because that's what sec is. And I can write that as y equals cos x to the minus 1. Now look, I'm putting the minus 1, so it's obvious that means 1 over. Now I'm going to use my substitution now, which I messed up my colours. That should be my substitution. So my u is cos x. So if I differentiate that, I get minus sine x. And now my y is u to the minus 1, which if I differentiate that, I get minus u to the minus 2. Times them to get dy by dx. The minus and minus makes a plus, so I get sine x times u to the minus 2. Well, that gives me sine x. Minus means still on the bottom, so u squared on the bottom, so cos squared x. Now here's the magic bit. I can write that as sine x over cos x, but I still have one more cos x on the bottom. That means it's just 1 on the top. Well, sine x over cos x gives me tan x. 1 over cos gives me sec. So I just get the answer sec x tan x. Done. However, you don't need to memorize that one, because in your formula booklet, you're given these ones. You're given a tan, differentiates to sec squared, cosec differentiates to minus cosec cot, sec differentiates to sec tan, and cot differentiates to minus cosec squared. Right, I'll do another video on using the chain rule to do some quick tricks.